Hello students, welcome to Sarat Chandra Academy. Today we will discuss JEE Main 23rd January shift 2 means evening paper discussion, and this is memory based paper. Okay, so let's start. Okay, we skipped few questions if we had a confusion in that, okay, because that question was not completely clear, and the questions which are completely clear or maybe possible little bit values can also change. Okay, that are only we are discussing. When an object is kept at a distance 8 cm and 24 cm from a convex lens, magnitude of magnification is same in both cases. Find focal length. Okay, so for different u, this is also u and this is also u. Obviously you have to take -8 and -24. So first of all, let's understand what is magnification. So magnification is v by u in the case of lens, right? Now you know 1 by v minus 1 by u is equals to 1 by f. So from here you can bring v is equals to uf upon u plus f. This you send this side and take the LCM. And then after v by u, that will come how much? F upon u plus f. This is only your magnification. Now if you compare what he is saying here, magnitude of magnification is same, not the sign. Okay, so actually what will happen, that the magnitude sign will be opposite. So one will have f upon -8 plus f, and one will be negative of f upon -24 plus f. Okay, like this it will be m1 minus m2. Okay, now here if you minus f cancel out, minus sign here and reverse it. So -8 plus f is equals to 24 minus f. Okay, f this side, 8 that side. So you will have f equal to 8 plus 32, 16 centimeter. Okay, so focal length came 16 centimeter. That's it. Okay, so that's it. This much only. Next we have time taken to achieve terminal velocity by a body depends on the density of the material, okay, rho, density of the liquid sigma, radius of material r, and viscosity of liquid eta. Okay, so time is dependent upon this. Like this he is saying k into rho to the power a, r to the power b, eta to the power c, and sigma to the power d. Then find b plus c divided by a plus d. Okay, so this is kind of unit and dimension question. Okay, so time is equal to k. K is a constant. Okay, so here t dimension time, then after rho is a density dimension. What density dimension? You can say m l to the power -3 to the power a, then radius means length, so l to the power b, right? And then eta. So eta, now as I have always told, that go with the simplest formula you can go with. Okay, so the formula which is coming in my mind is f is equals to 6 pi eta r v. Okay, so here obviously 6 pi is a constant. Force is what? Mass into acceleration, you can write down, right? So m l t to the power -2 is equals to, this is eta which I want, r is length, and velocity is length per unit time, so length square t to the power -1, right? So eta dimension what will come? If I'm fighting for, just want to get the dimension only as fast as possible, right? So m l this side power -1, right? 1 and -2. Here this will come -1, t to the power -1. So this is my dimension. Got the point? So let's write down that thing. Okay, so here l, and then after eta I got this. Okay, agree? Yes. M l -1 t -1 to power c, and density again sigma only, density, right? So this is m l to the power -3 only to the power d, so plus d also you can write down here. Okay, that I wrote till here only. This is, so now simplify a little bit. T, first of all, mass, where is the mass? M, so here m to the power, how much will come here? A plus d, and from here c, so you can say a plus c plus d, right? Then l to the power here -3a, and here -3d, right? And then after length to the power b here, and here length to the power -c. Okay, and then t to the power what will come? T is not here here only, so t to the power -c. Okay, now compare here, just t to the power 1 is there, right? So you can say a plus c plus d is 0, right? And -3a -3d plus b minus c is also 0. So -3, see here a plus d you want. So let me write down -3a -3d plus b plus, oh sorry, minus c. minus C is equal to 0, and minus C is equal to 1. So C equal to minus 1, right? So C equal to minus 1 if you put here. If you C equal to minus 1, you will put A plus D came. That A plus D I want here, right? So C minus 1, if you put A plus D will come how much? 1, right? So A plus D came 1. Now if you put here A plus D and C also, then B will come, right? So I will put that minus 3 common. See here, minus 3 common. A plus D will be 1. 1 and plus B minus C. C is minus 1. Okay? Is equal to 0. So from here B came how much? Minus 3, that side 3, and this is 1, that will be minus 1. So this is 2. Okay. So now you want B plus C divided by A plus D. So B plus C. B plus C means 2 plus minus 1 divided by A plus D, that is 1. Right. So this will come what? 1. So 1 is your answer, A option. Okay. So that's how you will solve. Next. The speed of sound at temperature this is V0 and temperature T2, which is alpha, not given. Speed becomes 2V0. Then find alpha. So in degree centigrade only we want, but we know that you have to go with the Kelvin, right? So what is the formula of the speed of sound? Under root of gamma RT by M, right? Only temperature is changing. So one time this is T1, right? And other time is 2V0. Okay, that time temperature is under root of gamma R T2 by M. Remember this T2 I am not finding out. I have to convert in degree centigrade. These are in Kelvin, right? If you divide, what will come? 1 by 2 square 1 by 4. T1 how much? 273 divided by T2. T2 came how much? 4 into 273. But this you don't want. You want in degree centigrade. This is in Kelvin. Okay. So degree centigrade you convert. So minus 273. 4 into 273 minus 273. That will be 3 into 273. Okay. This is your answer in degree centigrade. So accordingly we can tick. I hope so this is clear. Next. An air bubble inside water at depth h equal to 5 meter rises to surface. At bottom temperature is T1 and volume is V1, and at surface the temperature is T2. Find final volume. Okay. So here everything is in variable only, but I will give you basic understanding of the question. Okay. How we will approach this question. So what he is saying is that this is the water level. Okay. Here pressure is P0, below water is there. Okay. So at a depth of 5 meter. What you have to do, what is the concept of the question that we will deal with. So let me say this is h also. Let's deal everything in variable only. So let's say this is h height below, everything in SI unit, and here we have a bubble. Okay. Inside this bubble you can say number of moles conserved, temperature is changing, pressure is changing, volume is changing. Okay. So the conservation will only apply on the number of moles, right? So let's say when the bubble is here, bottom temperature is T1, volume is V1. And pressure will be what? So temperature T1, volume V1, right? And pressure is what? P0 plus rho G H. Agree? And here when this bubble will come on the surface, that time the temperature is T2, volume is V2, which you have to find out, right? And pressure will be P0. Okay? So you will say number of moles conserved, PV equals to nRT. In this you write down N is equals to, or NR also you can say constant only. So PV by T, right? So you can say P initial, V initial by T initial is equal to P final, V final by T final. Okay? So P initial, let's say this is initial your condition. T1 V1 by, P1. P1 pressure P0 plus rho GH. P0 plus rho GH. Volume V1 given. Okay. In the question, original question, it will be given in the form of the numerical value. Okay. Temperature T1, which will be given to you, is equal to P final, that is P0. Okay. Into V final, that he is saying to find out. And temperature T final will be given, which is T2. Okay, so between this point and this point you will apply the conservation of number of moles. So N into R is constant. Okay. Okay, generally this question comes, we say temperature constant, so number of moles and temperature both are constant, so PV equals to nRT everything constant, so P into V equal to P into V. That's what sometimes majority of questions comes. Okay, but this is also not that hard. Okay, let's go. A metallic sphere of diameter this and density this dropped in glycerin having viscosity 10 poise and density 1.5 gram per cc. The terminal velocity attained by sphere is. Okay, now here one thing you see, except this 2 mm, everything is in CGS unit, right? This is 10 poise is also CGS, this is also CGS, and the answer he is asking, velocity, terminal velocity of the sphere, that is also in centimeter per second. Okay, so everything he is asking in CGS, so deal in CGS only, right? Let's start. So you have the formula, terminal velocity formula is what? Terminal velocity formula, what is that? 2 by 9, right? Rho minus sigma, basically density of the body minus density of the medium, right? And what you write down here, r square g divided by eta. Okay, this is the formula. Now put the value, terminal velocity 2 by 9, okay, rho minus sigma, so density of the dropped in glycerin having viscosity this and density 1.5, and this is density 10.5, so you can say 10.5 minus 1.5 into r square, radius square, so that is 2 mm, get it in centimeter, right? So 10 is to power minus 1, so this is 2 into 10 is to power minus 1 ka whole square, sorry, not minus 1, plus 1. Plus 1, minus 1 only. Why I am getting confused? Square, okay, into g, that is 10. Got the point? Okay, divided by eta. So eta is how much? 10. Got the point? From here we can solve and we can get. This will 9 only, 9 cancel out and 4 something will come. Okay, 4 and here minus 2, 10 minus 2. That's it. Okay, pi r square. Why he gave density diameter of the sphere? Okay, then it is 1 mm na, 1 mm radius, 1. Fine. Now it is solved and 2, 2. Okay, so the A option answer. Next, a parallel plate capacitor with a plate separation 5 mm is charged by a battery. Okay, on introducing a mica sheet of 2 mm while battery is connected, so battery is still connected, it is found that it draws 25% more charge. Okay, so charge increases by 25%. The dielectric constant of mica is, okay, so there is a sheet introduced or a medium introduced. Okay, that's it. So this kind of question we have solved many times in the notes. See here, this is a capacitor which is connected with a battery. Okay, that means you maintained a constant voltage across it. Now here you are introducing a sheet, no matter where you introduce. Okay, how much? 2 mm. Okay, and total how much? 5 mm. So remaining how much? 3 mm. Okay, so initially before introducing this, okay, how much is the capacitance? So if you say C, A epsilon naught by D, so you will say A epsilon naught by distance is 5. Don't convert any unit. Everywhere you keep 5 mm only. Okay, no need. So this was the old before introducing this, right? So before introducing this, what was the charge? Q. So you can say the charge is CV. That's it. C, V voltage battery. Correct? Agree? Now after this, what you did is you change the capacitance. So here if you change the capacitance, the charge will also change. So he is saying that Q final is nothing but CV plus 25% of CV. That meaning what? Q final is how much? 1.25 CV. Agree? Then after, so this is the Q final. So get the C final, right? Then after you will have C final and this C capacitance, your relation, right? So final C equivalent will be how much? So here you can say this is 2 mm thickness you introduce. So this is kind of series combination with this 2 and this 3 mm with an epsilon naught, and here you have a K, which you have to find out. Okay, dielectric constant. So here dielectric material, here vacuum. So now see, C equivalent in series connection, what will be there? C1 C2 divided by C1 plus C2. So for that, if you will go, then you will say A epsilon naught by D, which is 3 mm here, okay, into A epsilon naught into epsilon r, which you want the K, okay, divided by 2, divided by C1 C2 divided by C1 plus C2. So C1 plus C2 write down. A epsilon naught by 3 plus A epsilon naught K by 2. Okay. Now calculate this. C equivalent equals to, here if you simplify, then what will come? See here 3 to the 6, and here also you take the LCM, that time 6 cancel out, right? But here 2 and 3K. So 2 plus 3K will be there, A epsilon naught cancel out, here common, and 1 remaining. So here you will have K times of A epsilon naught divided by 2 plus 3K. Okay, as far as I understand, this will come. Got my point? Okay. Now this is the C equivalent. So here you can say Q final. In this C equivalent terms, if you write down the Q final, what you will write down Q final? You will say Q final is nothing but C equivalent into V. That's it, right? And here you are saying Q final how much? 1.25 into CV, right? So just equate both of them. So if you equate both of them, let me change the pen. If you equate both of them, you will say 1.25 C V is equals to C equivalent into V, right? C value how much? A epsilon naught by 5. Okay, so put that value also. So you will say 1.25, which is nothing but 4 by 5, right? Sorry, 5 by 4. 5 by 4 into C, that is A epsilon naught by 5, and V will get cancel out, okay, and is equals to C equivalent. So put that value. So K A epsilon naught divided by 2 plus 3K. Okay, so here A epsilon naught cancel out. A epsilon naught cancel out, and we can simplify. So 5 also cancel out, right? And then what remaining? 2 plus 3K is equal to 4K, right? So K equal to 2. Agree? 4K, 2 plus 3K. Yes, K equal to 2. That's your answer, A option. Okay. Next. 2 point charges 7 microcoulomb, okay, at minus 9, 0, and minus 2 microcoulomb, which is at 9, 0, are placed in external electric field. E vector is given A by R, R cap. Okay, direction also given. Where A is 10 to the power 3 in SI units, find potential energy of system. Okay. Understand one thing. Here, when you will say potential energy total, that can be considered, one is between them, Q1 and Q2. This, you can say this is Q1, this is Q2, right? So K Q1, Q2 by R, that is the interaction potential energy, and they are also in the external electric field. So due to that also potential will come, right? So there will be an interaction potential energy between the charges, and there will be potential energy due to this external electric field, right? So if you find out first of all this due to external electric field, what is a potential, right? V will be what? Minus E dot dr, okay, which you have done many times, okay, infinity to R. So if you do that, okay, E value A by R, okay, I think it was A by R square, okay, here this is R square. So A by R square, what will come? Minus integration infinity to R A by R square dr. Okay, so what will come here? Minus 1 by R, right? And then you will put, so here this will come A by R. That's it, limits you will put. So A by R is the potential, right? So potential energy, when you are writing, just you multiply with the charge. So if you write down the total potential energy, right? So what you will say here? Interaction potential energy, first of all, K Q1, Q2 by distance between them. So let's say D distance I am saying, okay, D square, okay, plus for individual charges, you will say A Q1 by R, okay, whatever is distance from the origin, plus A Q2 by R, okay. Now put the values. So what you will have values? K 9 into 10 to the power 9 into Q1, Q2. So you have 7 microcoulomb and minus 2 microcoulomb, right? So you have 7 into 2, okay, minus will also come, right, and into 10 is to power minus 12, right, divided by distance between them is what, 18, right? So this is 18 SI unit only we have to consider. This is 18 square. Sorry, silly mistake I'm doing, but I'm good with this. Okay, 18 plus here k q1 I consider a positive charge, so here you will say a which is value given, but you can take the common, right? A by r you can take common, right? So a is 10 is to power 3 divided by r is also same. They are at the same distance, 9 minus 9 only, but that minus 9 will not matter here, right? So if you understand from this, if I put a point charge here, okay, this is like electric field due to a point charge only, right? So if you, from this center, if you check the electric field, okay, electric field will go this direction, positive, negative. But if you check the potential, right? So here potential this side and here potential this side at the same distance, value will be exactly same, right? So R is 9 and Q1 plus Q2. So Q1 plus Q2 7 and minus 2. So this will be 5, right? 5 into 10 is to power minus 6. Got the point? Okay. I hope so this is clear. Next. In this, if you simplify, what will come? 9 to 18. So let me change the pen. 9 to 18. Okay. And here 18, 7. Right. So this will come how much? Okay. 7. This is minus 3. Minus 7 into 10 is to power minus 3. And here plus 5 by 9 into 10 is to power minus 3. Okay. So this will come how much? 9 into 7 plus 5. So this is minus sign, right? So this is 63, right? 63 plus 5. 63 minus 5. 58, right? So minus 58 divided by 9. 10 is to power minus 3. That is your overall potential energy. And obviously in joules, right? Everything in SI unit. So according to that, we can say A option. Got the point? Next. A particle is projected from bottom of inclined plane, okay, with a speed u. Find distance covered along the plane before coming to rest. So he will go up and at a certain point it will come to rest, okay. So instead of applying work energy theorem or something like that, just apply the simple kinematics, okay. That will be very little bit faster here. So along this plane, if I say that, then downward acceleration what? G sin theta, right? Friction here I have not talked about, okay. So downward acceleration opposite G sin theta, so he will go, when he will go up, he will slowly decelerate, right? So certain point here velocity will become 0. Let's say along this plane only length he travel L, right? That L he is asking, right? So which equation you apply? Initial velocity you know, final velocity you know, and the acceleration you know. So, and you have to calculate length, okay? This I have told many times that in the equation of motion, when we apply 3 equation of motion, that time every equation, if you will see, they are carrying 4 variables, okay, and overall there are 5 variables there are, okay. So in any equation there will be 4 variables. So if between 2 points when acceleration is constant you are applying a equation of motion, if you know 3 variables, you will definitely find out, you can make sure that okay, we will get some equation. So here I know initial velocity, final velocity and acceleration. So just you have to find out which equation to apply, okay, and we practice so much that it will come automatically. So you can say S is equals to ut plus half at square. That will be not applicable. So which one? V square equal to u square plus 2as. Yes. So V square equal to u square plus 2as. So final velocity square 0 square plus initial velocity square plus 2 acceleration what? Opposite to the initial velocity. So that I am taking minus g sin theta. And the displacement is L. So L will come how much? U square by 2g sin theta. Okay. U square by 2g sin theta. So I think A option. Got the point? Next. 4 charges are kept as shown in the figure. Find magnitude of electric field at point P. P is the midpoint of line AB. Okay. So here you have to understand that this he is talking about something like dipole. Okay. Where according to this dipole, okay, he is on the equatorial position, right? and according to this dipole he is on the axial position, right? So if you have seen 2025 JEE Advanced paper, there also dipole question came, right? So I hope so that those concepts at least you have done JEE Advanced PYQs, right, while you are studying 11th 12th, right? So obviously you have remembered the formulas. So let's start. Okay, in this first of all I will solve in variable terms and then I will put the value, right? So here 1 centimeter, so distance this D I am considering 1 centimeter. So this also gap between the charges, this is D also 1 centimeter, right? Here 2 microcoulomb charge I am considering as Q. So this will automatically become how much? 2Q, right? Q value I will put later on, right? And here this gap is given 40 centimeter, that you can consider as R. Okay. Now if you find out electric field, right, at the P point we want the electric field. So if P point you see, according to this dipole, which dipole have positive charge this side, negative charge this side, so this dipole is facing this side, dipole pointing that side, right? So this is which position? Axial or equatorial? Axial, right? So he will be direct, this side only it will be direct. So according to this dipole, the electric field which will come here, it will be this direction, right? I am naming it E1. By the P1 dipole, it will come E1 this side, okay? And P2 dipole, this I am naming it as a P2 dipole which will facing up, right? Okay, and according to this dipole, which direction electric field will come? He is in equatorial position, right? So according to P2 dipole, it will be minus, you remember, minus Kp by R cube, right? So minus Kp by R cube means downward, that's it. Okay, so that will be your E2, let's say. So E1, E2 value let's find out. Okay, let's E1, E2 value write down. So net electric field we will write down later on. First of all, say E1. E1 will be what? E1 will be 2K P1 by R cube. Okay, and E2 will be what? 2K P2 by R cube, right? Let's put the value of 2K P1. P1 value how much? P1 is nothing but Q into D, right? So this is Q into D divided by R cube. R cube is same only 40 here. So R is same value, right? I don't want to put many times, that's why. Okay, keeping the solution as less as possible. Sorry. Here E1 will be 2. In E2, 2 will not come. Okay. Minus comes na, but minus I have already considered. Minus I have already considered that it will be opposite to P2. Right, so Kp by R. So here what will come? K P2. P2 will be what? So P2 is 2Q into D. Right? So 2QD divided by R. If you see overall the magnitude wise both came same only. So that's a good thing. Right? So if net electric field when you will solve, net electric field when you will solve E net, right? Both E1 and E2 are perpendicular, right? And both magnitude wise also same as we can see here, right? Magnitude wise same, so what will come? A and A resultant what? A root 2, right? Under root of E square plus E square is root 2E, right? So this answer is what? Root 2 times of 2KQD by R cube. Okay, so let's put the value root 2 into 2K value 9 into 10 is to power 9. Okay, into Q value what I said, 2 microcoulomb, so that will be 2 into 10 is to power minus 6 into D is what I said, 1 centimeter, right? So that is 10 is to power minus 2 divided by R cube. So R cube is what? R is what? 40 centimeter, right? So 40 centimeter cube. So your 40 centimeter cube means you can say 0.4 or 4 into 10 is to power minus 1. So you have 4 cube into 10 is to power minus cube is 10 is to power minus 3. Okay. So that's your thing. Okay. I hope you will be able to simplify this. You can match this. Now this is easy thing. Okay. Our motive is to complete like concept. Okay. What concept he is asking so that you can prepare for the next paper. He can ask you this. Right. That's not a big deal. Next, dielectric constant of a medium is 3, okay, and its magnetic permeability mu equal to 2 mu naught, okay. Find ratio of velocity of light in vacuum to velocity of light in medium, okay. So if you see here, he just tweak the question velocity of light in vacuum, C, velocity of light in any medium, that is nothing but refractive index, right? So refractive index formula, see, he is what he is talking about, dielectric constant, right? That is what, epsilon r, right? And here mu r what? Okay, relative permeability is what, 2, right? And here this is 3. So this is nothing but mu r into epsilon r, right? So what is that? Under root 6, 2 into 3. Got it? So root 6 is your answer, B option. Okay. Next, a prism with angle of prism 75 degree. Okay, A is given here 75. Have refractive index root 3. So is refractive index root 3. Has a slab of refractive index 1.5 kept on one side of the prism as shown. So this side we kept mu equal to 1.5. Find angle of incidence such that TIR occurs at the slab prism interface. Okay, so TIR should occur here, right? Let me draw what will happen. So here ray coming, this one interference, and here the TIR happen. Okay, so what is this? So you can say this is 90 degree. So this is R2, right? Automatically this is R1, right? So you can say what is R2 first of all. I hope general convention you know. Here we say angle of incidence R2, right? So you will have root 3 into sine R2 equal to 1.5 into sine 90, right? So sine R2 what? 3 by 2, right? Root 3 by 2. So R2 came how much? R2 is how much? 60, right? 60 degree. So R1 is what? 15 degree, because R1 plus R2 is only angle of prism, right now? So this will give how much? 15 degree, right? So 15 degree, now apply here Snell's law. So what you will say? 1 into sine I is equal to root 3 into sine R1, right? And sine 15 how much? 0.25. 0.25 means 1 by 4 you will put here. Okay, this value 1 by 4. So you will have sine I equal to root 3 by 4, right? And that is when you will solve here, root 3 value, root 3 by 4 when you will put, it will come root 3 1.732 433. Okay, 433. So according to that you will come to know I is approximately 25 degree, right? So you have to keep below 25 degree, right? So your answer should be below 25. So here he typed mistaking there. Theta should be less than 25 degree, then TIR will occur. Because if you will keep the I less, then your R1 will be less, so R2 will be bigger than the critical angle and TIR will happen. That's why theta you will be considered less than 25. Less than 25 any value, right? That's why most suitable option is the B option. Got the point? Okay. Next. When an unpolarized light falls at a particular angle on a glass plate, okay, it is observed that reflected beam is completely polarized and the angle of refracted beam with the respect to the normal is, okay, so angle of refracted ray he is asking. Okay, let's see. Options are written actually, but it is in the black, so maybe not possible visible. It's okay. Let's understand what he is saying. So he is talking about the Brevister's angle, which we have studied in wave optics at the end. Okay, so if you will see here, last year JEE Advanced also question came. If you remember, a sphere question was there in the which another medium was there, in the cavity was there, I think cavity or some other medium, and it hit, and there it was the polarized light was coming. Okay, so that was the one question there. Now here what is happening? Incidence I, right, and then this is reflected and this is refracted, right? So reflected light is polarized, so that means this angle is 90 degree, right? This is also I and this is also R, so you can say I plus R equal to 90 degree. Okay, now see, now what we will say? We will say I plus R equal to 90, apply the Snell's law. So you will say mu. He is saying an unpolarized light falls on a particular angle on a glass plate, right? So this is glass, so 1.52, right? This is 1. Okay, so 1 into sin I is equals to 1.52 into sine r, right? Now understand, here he gave one value to us, tan inverse 1.52 means tan theta equal to 1.52, tan 57.3 degree is equal to 1.52, right? So I have to create here tan, right? So remember, like here he is asking r, you can go for directly r, but I will not go r, I will get the I, then I plus r equal to 90, because I want to create tan, right? So here I can say r value how much, 90 minus I, that will be cos I. So cos I this side, tan I. So tan I how much, 1.52, that means I is how much, 57.3 degree, right? And I plus r is how much, 90 degree. So r is how much, 90, you can subtract. So you will have what, 36.7, right? 36 or 60, 32 something, 28. Okay, you can subtract 60, 30, 38, 32.7. Is this? Got the point? Okay. R only is asking an angle of refracted beam with respect to the normal is. Okay. I think so. Correct. Okay, indeed. That's it. Next. Logic gate circuit, choose correct truth table. Okay, we have to choose the correct truth table. Okay, but we can solve directly. If you will solve, let's start with this. So here, I hope this is visible. Okay. Okay, let's start. So here what we say, A input here, and here in the OR gate is there where one input is A and one input is B. So what will come? A plus B. And here in this input is going A and A plus B. And what is this? NAND gate, right? So A and A plus B with a NAND gate. So first AND operation, then NOT operation. So you will have AND operation means A dot A plus B and then whole bar. This is your answer, right? So if you simplify this, you can multiply inside first. Agree? Multiply this. So what will come? A dot A plus A dot B, right? So A dot A is what? A dot A is always A, right? A and then A common, so you will have 1 plus B. 1 plus B is what? Always 1, right? So you will have just what? A dot 1, right? A dot 1 is what? A, right? So A bar. So final answer is what? A bar. So A bar you have to take. So C should be what? A bar. C will be nothing but A bar. Okay. So here 0, 1, 1, 1. No, this is not. 0, 1, 1, 0, 0, 1, 1, 0. So I think B option correct. Okay. If you will see here 0, 0, that is not the correct. 0, 0, that is also not correct. So B option is correct. Okay. Here what this logic gate answer is? A bar. Okay. So logic gate is coming in every paper almost, right? So you should be ready with these things. A parachute jumps, okay, from a helicopter. It falls freely for 2 seconds. Okay, spelling wrong here. He opens parachute which produces retardation of 3 meter per second square. When his height from the ground is 10 meter, his velocity is 5 meter per second. Okay. Find his initial height from ground. Fine. Here see, what are the things given? He jumps from a helicopter, so you have to assume initial velocity 0. Okay. Then he travels for 2 seconds. Okay. Or travels for 2 seconds. Free fall. Free fall means here gravity is also given. Is falling under gravity. Okay. And then after from here, he will have a retardation about 3 meter per second square. Okay. And after this retardation, here see, when his height from the ground is 10 meter, his velocity is 5 meter per second. So here is the ground, okay, and somewhat above, how much? 10 meter. 10 meter above from the ground, right? At that point of time, he have a velocity, how much? 5 meter per second. These are the values given. So he is asking his initial height from ground. From here to here, you have to calculate the height, okay? So now understand, he gave this velocity. Here we know the acceleration. Here we know the time. So in this motion, here to here, you know 3 things. As I told in that first question, one question also, that if you know the 3 things, you can find out anything. right? So let's find out. Okay, so here velocity, let's say I'm naming it v, right? And the distance also, let's say this is distance is s1, which you want to get. Here the distance is s2, which you want to get. Okay, so s is equals to ut plus half at square, that you can apply. Okay, so s1 will be what? Ut plus half at square. Ut is 0 because here 0, plus half acceleration 10 g into t square, that is 2 square. Okay, so 20 meter, right? And then v also find out. So v is equals to u plus at. U is 0 plus acceleration 10 into t is what? 2. So this is 20 meter per second. Okay, so v is also 20 meter per second. S1 came, S2 also. Now here you know the initial velocity. Between this point and this point apply. You know the initial velocity, you know the retardation, right? Two things. And what else you know? You know the final velocity also, right? So you can get the S2. S2 how you will get? V square equal to u square plus 2as, right? So we can apply v square equal to u square plus 2as. Okay, remember acceleration is constant, that's why. Okay, final velocity square, 5 square is equal to u square. U square meaning what? This one. Okay, which is how much? 20. So 20 square plus 2 acceleration minus 3 into s2, right? So from here s2 will come. So that is 20 plus, I want to go one step faster, but it's okay. 20 square minus 5 square divided by 2 into 3, right? That is your answer of S2. So that will be how much? Your 400 minus 25. So this is 325, 375 by 2 into 3. Okay, that's it. So this we can simplify S1. Now your final answer will be nothing but S1 plus S2 plus this 10. Okay, this is your answer. Okay, this we can simplify. I think points answer should come, right? It will, I'm seeing, and one only option is there in the point, C option, right? You can solve also, that's your headache. Next. Okay, this question repeated again. Fine. 1 mole of diatomic gas is expanding isothermally from V to 2V, okay, at 27 degrees centigrade. If the magnitude of work done by gas in this case is same as the work done in adiabatic process, where initial temperature is 27 degrees centigrade and final temperature is T degrees centigrade, then T is, okay. So work done equal 1 mole of diatomic gas. Diatomic meaning what? If we need isothermally, we have expansion, magnitude of work done. Work done in isothermal is what? nRT ln V2 by V1, V final by V initial. Remember, right? So work done will be how much? N, number of moles, 1 mole, right? R T. T is what? 27 degrees centigrade. So you can say 273 plus 27, 300, right? 300 ln 2, right? This is work done. And this work done is equivalent to the adiabatic work done for the process where initial temperature is 27 and final temperature is T, right? So work done in adiabatic process is what, right? I say don't remember so many formulas, okay? Thermodynamics is the easiest chapter possible in physics, right? Q is equals to delta U plus W, right? Q is 0, right? So you can say directly here work done is equals to negative of delta U, and delta U is always F by 2 NR delta T, right? So work done is nothing but minus F by 2 NR delta T, and delta T is always T final minus T initial, right? That's it. Now here people do with gamma and then negative sign inside, T initial minus T final, then 5-6 formulas they write down. Don't do that thing, okay? Don't go with that nonsense. So here if we put that value, okay, that is equal to this value, right? So we have 300 R ln 2 is equal to their F by 2. So here he said diatomic gas, diatomic means degree of freedom 5, right? So minus 5 by 2, N is 1. N is 1 into R, and T final minus T initial, right? So initial temperature 27 degrees centigrade, final temperature T. So minus is there, so T final, that is T minus 300. Okay. Now here you can send this minus inside, and now you can simplify for the T. Got the point? Okay, and then you will get your answer. And this answer, remember, it will come in, not in degree centigrade, but it will come in Kelvin, right? If you want in degree centigrade, here only instead of writing 300, you write down 27 degrees centigrade, answer will come. Okay, I hope so this is clear. LN2 value you have to put. Got it? Maybe it will be given in this, but I hope you remember also. So this can be simplified easily and you can get the answer. Next. A bomb at rest explodes into 3 pieces in the ratio of masses 2:2:3. The identical masses fly off perpendicular to each other with 18 meters per second. Find speed of third piece. Okay, so this is like many times you have done maybe in the tests. Okay, so he is saying 2m mass this side, with an 18 meter per second, right, in J-cap lake, and 2m mass this side with an 18 meter per second, right? And let's say that 3m mass, right, went in a particular direction, let's say with v vector. That v vector you have to find out the magnitude later on, right? So initial rest explodes, so we can say conservation of momentum, right? So initial momentum how much? 0, rest, right? And final momentum, this have in J cap and this have in I cap, and this will have in certain direction which we have to find out. So initial momentum 0, final momentum also should be 0. So his momentum how much? 2m into 18 J cap plus 2m into 18 I cap plus 3m into v vector equal to 0. So m cancel out, v vector will come how much? Here 18 to 36, 36 take common and divided by 3 is there, right? So 36 by 3 into I cap plus J cap, with a negative will also come, but he wants the magnitude, right? So this will be 12, v vector is what? Magnitude 12 root 2. Okay, so I think 12 root 2 is answer, so that is A option. Got the point? Next. Number of photons required for a light beam of 2000 picometer wavelength and 1 joule energy is. Okay, so correct statements you have to find out. So first statement, how you will say correct or wrong. For that, see, number of photons should be this much for a light beam of this much picometer wavelength. So you say total energy what? 1 joule, right? And 1 photon's energy is what? Hc by lambda, right? So hc by lambda given 2000 picometer. So I hope so. Picometer is what factor? 10 to the power minus 12, right? So by that you can convert. And this number, okay, if you will find out, it will come approximately equivalent to this. Okay, so this statement will come correct. Next question by mistake. Okay, here 16. So this will come, so that means first statement is correct. You can solve hc value, we know everything. Light with wavelength 300 nanometer has energy E1, and for wavelength 900 nanometer has energy E2. So E1 by E2 will be 1 by 3. Let's check this one also. E1 by E2. E1 how much? hc by lambda. So hc by lambda. E1 have lambda 300. Nanometer factor conversion will be same, hc by 900. So if you will see here, this is 3 by 1, not 1 by 3. Right? So this is wrong. So second statement wrong. First statement correct. So 1 is correct. Okay. Then after third one, frequency of light is 4.5 into 10 to the power 16. Then its wavelength is 6.7 into 10 to the power minus 9. So you can say speed of light is equals to what? Frequency into lambda, right? So if you multiply frequency and lambda here, 4.5 into 6.7, and this factor also, this will come equivalent to C, right? That means third statement is also correct. Got the point? Fourth, if electrons and protons are accelerated by same potential difference, then their de Broglie wavelength are equal. No. Why? Because de Broglie wavelength formula is h by momentum, that is under root of 2m kinetic energy, and accelerate, so it will be q into v potential, right? So here mass and charge multiplication, maybe potential is same, but mass and charge multiplication factor, it will be too much different for the electron and proton. Charge is same, but mass is very much different, right? So lambda will be different, not same. So 1 and 3 are correct. So that is C option. Okay, that's it. Next. Internal energy of gas is given as U equal to 3 nRT. Okay, 1 mole helium gas takes 126 joule heat and its temperature rises by 4 degrees centigrade. Okay, atmospheric pressure is P naught and the area of piston is 17 centimeter square. Find distance moved by piston. So basically the piston is movable. So you can consider this is what? Isobaric process, right? So isobaric process, what you will write down? Q is equals to delta U plus W, right? Delta U given here. Q is equals to delta U is what? 3 nR delta T, right? Plus W. W will be P delta V or nR delta T, whatever you write down. This nR delta T can be written as P delta V because P is constant, right? And Q is given. So Q is given how much? Value given na here somewhere 126 joule, right? 126 joule is equal to 3 times of P delta V and this is P delta V. So this is 4 times of P delta V and P is how much? P is 10 to the power 5 into delta V. Delta V, how much you will write down? Delta V, how you will say delta V? So for that you see area of cross section into how much length he will move. That is only change in volume, right? So you can say area of cross section which is 17 centimeter square, right? 17 into 10 to the power minus 4. Okay, this will come into distance whatever delta x he will move, that distance you want to answer, right? So here change in temperature no use, that's it. So that delta x will come in SI unit, you can convert in centimeter. Got the point? Okay, that's it, clear. Next, disk of mass m comma r is given. 2 discs of radius r by 4 are cut from this. Okay, this diagram is not accurate. Okay, whose center are at 153 degree angle. Okay, this 153 degree angle. Their peripheries touch larger disc as shown. If moment of inertia of remaining disc about center is alpha by 256 mr square, find alpha. Okay, so for the remaining one you have to find out. So for the original disk mass is given m and radius r, right? This question became easier on that side. Other way it becomes like after removing, if he is saying remaining mass m, right? Then the density calculation will be way different. Okay, so here let me draw the diagram again for your reference. This is the disk, this is center, here is one disk. Okay, r by 4 radius means r by 2 it will cover, this is r by 2 remaining. Okay, and here is one disk. Always okay, something like this. Here center here, he have center here. Okay, let's start. So first of all you go for the density as we always do, right? So for initial sigma, right, disk na, so areal mass sigma is what? M upon pi r square, right? Now you write down the moment of inertia, right? That's it. So moment of inertia will be what? And try to understand one thing before this writing. Okay, moment of inertia, how you will write down? Total disk moment of inertia minus moment of inertia of this disk about this axis and this disk about this axis. Okay, so that's how you will write down. Okay, and if you don't remember, okay, we have done questions like this. This have this here shaded region, right? Plus this disk equivalent to the complete disk, right? That's it. So I hope you have done basic questions on this. Okay, so that's it. Moment of inertia, total moment of inertia, what? Disk, right? So mr square by 2 minus 2 times of, because there will be 2 disks, right? For one I am writing. Okay, so for this disk, then you will write down, right? Let's say this disk which you removed, he had mass small m. Okay, if you understand, small m will be how much that I want to take. Small m will be how much if I want to calculate? So it will be sigma into his area. Area how much? Pi r by 4 square. So that is how much? Pi r square by 16. And sigma is what? M upon pi r square. So this will be capital M by 16. Okay. I hope so this is clear. So there is a small m value. I'm taking small m only, or I don't want to put everything together, okay? So let's put one by one. So here 2 into first this disk about his own center. So I'm applying ICM plus MD square here, okay? So ICM will be how much? MR square by 2. That's it. So m is small m, r is r by 4 divided by 2, mr square by 2 plus md square. So small m into d. This distance is how much? So you can say r by 4 and r by 2. So r by 2 plus r by 4, basically r minus r by 4. R minus r by 4, 3r by 4. So this will be md square, md, 3r by 4 ka square. Okay, this will be your answer. Okay, small m value we can put and then we can solve. So first of all, mr square out. Okay, 1 by 2. Here see what will happen. So here you have minus 2 into now factor. For factor, small m is what? Capital M by 16. Capital M also out. 1 by 16 factor will come 1 by 16. Okay, that 16 into 16 will only create that 256. Okay, here. So here see what will come, 2 into, this is 1 by 2 into 1 by 256. Okay, plus here what will come, 9 by 256. Okay, multiply it inside. Okay, and what you will have, if you multiply this inside, this 2 factor if you send inside, this 2 gone, right? And here you will have 18. Right? This is 18 plus 1, 19, and then 256. Okay. So you'll have I is equals to mr square. Okay. 256 LCM. So 256 LCM will come. Then what will be there? 128 minus 19 divided by 256. And this is equal to what? Your alpha by 256 into mr square. So if you compare, your alpha is nothing but 128 minus 19, right? So that will come how much? 109 something? Yes? Yes, 109 alpha. Okay? Yes. Next. The equilateral triangle frame has current 2 ampere. The side of frame is 4√3 centimeter. Magnetic field at center C is, right? So this kind of question there in the notes, right? So just you have to find out this distance and angle. Okay, so let's see. I'm taking one side and then I'm explaining this question, right? So if you will see this, the below wire, right, which is of side A, let's say, right, from the center, right, this distance, tell me how much will be this distance, R. Okay, so R, you can say R is what? Here if you take it equilateral triangle, so medium, orthocenter, everything, he is only this. Orthocenter, in center, centroid, everything is this, right? So 2:1 ratio, perpendicular. Basically, I don't remember these things, okay? Basic things. What is the side, what is 1/3 ratio? This is A, this will be A sin 60, right? And A sin 60, 1/3, right? So 1/3 of A sin 60, √3 by 2. So R will be what? A by 2√3. Okay, this is your R, right? And angle, if we talk about, what angle he will subtend? So here 60, so here directly you say 120, right? Or you can say this half angle 30, so this is 30, so this is total what? 120, so this is 60 degree, and this is also 60 degree, right? So now remember the formula here for this particular wire which have a current I. How much will be the magnetic field? So by that magnetic field we say mu naught I by 4 pi r sin theta 1 plus sin theta 2. Okay, so if you put the value, okay, he is asking value only. So at magnetic field, when you will talk about by all three, it will be added. By this wire also it is outward, by this wire also outward, and by this wire also outward. So overall magnetic field you will have 3 times multiply, right? So 3 mu naught is what? 4 mu naught by 4 by 10 to the power minus 7. Mu naught by 4 by 10 to the power minus 7. Okay, current is 2 ampere. divided by r is what? A by 2 root 3. A is what? 4 root 3, right? So if you put the value here, right, what will be that? 4 root 3 to 10 to the power minus 2 divided by 2 root 3. That is what? 2 into 10 to the power minus 2. So this is 2 into 10 to the power minus 2, right? And sine theta 1 plus sine theta 2 means both are equal only, sine 60, sine 60. So 2 times of sine 60, that is root 3 by 2. Okay. So magnetic field, how much? 2 cancel out. Here 2 cancel out. And root 3, 3 root 3. Okay. And this is 10 to the power minus 5. Right. Micro 10 to the power minus 5, 10. 3 root 3. So 30 root 3, 10 to the power minus 6. Right? Correct. So micro Tesla. So 30 root 3 answer. So A option we can tick. Getting the point? No mistake. 33, 35, 6. Correct. Next. An experiment is performed, and this also I have told, if you make silly mistake, if you have analyzed your grand test papers or before that whatever paper you have gave and you are going above, you can say 12 about 12 negative if you are going, right? Then that means you are making too much of silly mistake if you analyze per question, every single question, right? Then you should, after like how I did here, after my answer came, still I gave 5 seconds to see that once it is not wrong, right? That way you have to check that is it wrong, okay? Because you are applying so much of brain and so much of time you are investing, and then finally you make a silly mistake, because of that your answer comes wrong. That is very wrong, okay? That is very, very silly mistake. So to avoid silly mistake, what we do, we give a, like which question we gave full potential and we know 100% correct. If that gets wrong, that's a very wrong thing. So because of that, we will apply 15 seconds. Okay, give a 15 second and then check. Okay, this. Now to do that, we have to, in the rough notebook only, when we are solving, we have to little bit of order. Okay, we have to follow little bit order so that we can at least check our rough notebook, right? If you will write down something here, something here, something here like that, then you will not able to analyze it. Okay, not after completing paper. No, that time only just 10 seconds give. Okay, here this calculation correct, this 3 multiplication factor correct, this came okay, correct, like that. Okay, next, an experiment is performed for comparing EMF of 2 cells using a potentiometer. For first cell, balancing length has achieved at 200 centimeter, and for second cell it has 150 centimeter. If least count of measurement of length of potentiometer wire is 1 centimeter, the percentage error in the ratio of EMF of 2 cells. Okay. See one thing, in potentiometer, when you say the voltage, right, that will be your potential per unit length into length. Like let's say L1 for the V1 at EMF E1, let's say. Okay. And E2 you will have lambda into L2. Okay. Like that you will measure. Now if you go for the ratio, it will be nothing but E1 by E2. That ratio you are finding out, that you call it R is resistance, but here I am calling ratio as, okay. So that is lambda cancel out, L1 by L2. Now you take for the, what we say, percentage error you are solving. So here what you see here, R equals to L1 by L2, and L1 and L2 have a percentage error. Like you can see he gave least count and all. So what you will do? This is in division, right? So for that you will go for delta R by R is equals to ln and differentiate, right? That you should remember. So here delta L1 by L1 minus delta L2 by L2. But here because we are dealing with error, so plus will come. ln differentiate, then minus will come. But if you are dealing with error, then plus will come, right? So delta R by R. Remember this R is not resistance, this is ratio. So delta L, right? So how much least count? 1 centimeter, and lengths are coming how much? 200 and 150. So here this is 1 upon 150 plus 2 upon, sorry, 1 upon only, 1 divided by 200. 1 divided by 200. Okay. So from here this is fractional error. Okay. And if you want in percentage, and you multiply this with 100. So this is 150, 200, I think 600 ratio. Right. So 600, this will be 4 and this will be what? 3, and into 100 for percentage. right? So this answer came in percentage. So this is 7/6. 7/6, B option. Okay, so B option is the correct answer. A small ring is given some velocity along the axis of a solenoid and it remains coaxial with solenoid. Current in solenoid I equal to 10 sin omega t, omega given. Number of turns per unit length is 500 per meter. Okay, means number of turns per unit length is given. That only we need. Okay, radius of ring is 1 centimeter and its resistance is 10 ohm. Find RMS value of induced current in the ring. Okay, so 3D diagram I will not draw. Okay, basically solenoid, if you see here like this, solenoid here rings are there. Okay, outward towards you like this. Okay, cylinder kind of. And in this a very small ring, that's why he's saying the ring is not big, outside also, inside only. Okay, here only one small ring we are sending inside, right? So and this ring is coaxial, means same axis, both have the same axis. If both have same axis, now inside this, what we say, solenoid, what will be the magnetic field? Mu naught Ni. Remember, mu naught Ni. Okay, so mu naught Ni only you have to consider that value only. Okay, infinite solenoid only you have to consider, right? So mu naught Ni. So the EMF that will be generated in this small circular loop, that will be how much? That you can say EMF will be area into your, you can say d phi by dt. Okay, so that will be d by dt of, minus will come, minus we are not dealing with, into area into magnetic field. Okay, so magnetic field is mu naught Ni, right? So magnetic field is mu naught Ni, right? And I is how much? 10 sin omega t. So mu naught N I is what? Like let's say this, call it I is nothing but I naught into sin omega t. Okay, I don't want to deal with variables. I naught sin omega t. Okay, and now differentiate. So EMF will come. Now answer is not giving EMF also. He is asking RMS value of induced current in the ring, right? So here we have resistance. Okay, so this loop have EMF generated. That EMF we can calculate from here. And then he have a resistance, right? So EMF generated, resistance it has, so current will come. So that I will be what? EMF divided by resistance. V equals to IR in this loop, right? So EMF value if we calculate here, what will come? A mu naught N I naught out, sin omega t differentiation cos omega t, and omega will also come. So you will have mu naught N I naught A omega cos omega t and divided by R. Okay, and if you are going for RMS value, then if you will calculate RMS, so his value will become 1 by root 2. Okay, right? So that way 1 by root 2, so you can put. Okay, so I think everything is given. Mu naught you can put 4 pi into 10 to the power minus 7. N value is given 500. I naught value is, you can take 10, right? Omega value given 1000. Cos will go. R value given 10. Okay, so all values are here, and that's it. Okay, area is what? Pi r square. Area is what? Pi r square. Okay, that's it. Okay, calculation is not the thing, just you have to understand the concept. Okay, that's it. So solenoid is also important, he can ask you. Remember, he is repeating the concept once or twice, right? So you have to understand the concept for the next paper when you are going. Okay, I think this is the last question. Which of the following is isobaric pairs, right? So for isobaric pairs, you can say the sum of neutron plus proton should be equal, right? So here I can say 3, 13, 3, 3. So B option is correct option. Okay, isobaric. So for that we can say number of nucleons, right? Proton plus neutron. So that is here 3. Okay, so 3, 3. So B option is correct answer. Okay, that's it. So I hope so this is clear. Okay, and best of luck for all of those who are remaining. Okay, thank you.